Good morning, sir.
Good morning, sir.
Very good morning to all of you.
Very good morning, sir.
Good morning, sir.
So you are feeling good in online class?
Yes, sir.
No, sir.
Why it is yes and why it is no? It is easy to listen?
Yes, sir.
And there is no time boundary, right?
Yes, sir.
We'll start the class.
Yes, sir.
My screen is visible.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Can you tell me which chapter we are starting today?
Network security.
Very good. So the last unit, network security, is very easy. I suggest you to not to leave this unit. Most of the time, student leave this unit, but this unit is very easy. You can score good marks. You need to concentrate because of most of the topics which we discuss in this network security, you can write good points and you can write good diagrams and you can score good marks also. Basically, how do we define the security is the question. What is network security? What are the principles of network security? This is most quite frequently asked questions. We say network or anything with respect to the security is concerned, data security, network security. Three important points: confidentiality, integrity, authentication. We call them as components or principles of security: confidentiality, integrity, and authentication. Confidentiality is maintaining, encoded data secrecy will maintain. If you are having the sender and receiver, then the confidentiality is only between, the information is only between them, and third party cannot understand the data. Confidentiality. Integrity is maintaining integrity of the data, integrity of the message. We have seen, we have used some algorithms to find the integrity. What are the algorithms? MD5 and SHA1, for example, right? We have used it, right? In the beginning of the classes, any responses?
Yes, sir.
Yes, sir.
MD5 we have used it, SHA1 we have used it. If there is a small change, a comma is put, a hash is put, a special character is put, a space character is put, what happens? There is a large change in the output of the hashing algorithm. Message integrity. This is to find the message integrity. Authentication. Authorized person only should use the data. If authorized person is not using, we should be able to identify it. Authentication. So there are three important parameters which defines the security: confidentiality, integrity, authentic, and availability of the data. Availability of the data means authorized person only should be made available the data. On top of it, we have non-repudiation also as one of the important parameter. What is non-repudiation? I will send some mail or I will send some message, and the source of the message we should be able to identify, because if somebody says I have not sent that message, we should have some evidence. We should have a protocol which identifies the source of the message, who has sent the message. So that one is not able to deny the message sent by him. That is called non-repudiation. We use the internet. Internet has given enough opportunity to bring several security threats. Yes or no? Internet has become a platform for many of the security threats, right? So security threats are more on the internet. Let us see what are the things that comes in this chapter. We take a situation where the customer makes a credit card transaction. See, threat can be against a person, threat can be against a website, threat can be against a government. There are different types of threats. Now we are taking a case where customer is using a credit card to order an item from a website. What are the possible threats here? An adversary who illegally, unauthorizedly eavesdrop on your communication network, and he reads the messages to obtain the credentials of the credit card information or transaction. It's possible and practical, however, to encrypt messages. Say if somebody reads your message, then we want to avoid it. The third party should not use your information. Then what you do is you will encrypt the message so as to prevent adversary from understanding the message content. A protocol that does so is said to provide confidentiality. And taking the concept a step further, extending this confidentiality from the sender to the receiver through the network, we can call it as a traffic confidentiality. We said adversary eavesdrop and collect some, say, credit card information. If we encrypt, the problem is not over. Still, there remains threat for the website customer. What is that? I may not understand what information is being flown from the sender to the receiver or receiver to the sender, but still I can make some changes in the ongoing being transferred message. I can make 100 as 1000. I can say instead of 1000 rupees being transaction, I can make it 100 or 10 or 10,000. Some changes I can make. Therefore, if the message is made some changes, then it is not integrity of the message. Even though we are not able to make tamper proof, at least we can identify the message in transit is modified. That is, data integrity we can implement. So, as we have already discussed, MD5 and SHA-256 are some of the algorithms. Using them, we can find out whether the data sent, the same data is received at the receiver or different data is received. So we have come across two things. One is eavesdropping. So in order to avoid eavesdropping, we have to bring in confidentiality. To achieve confidentiality, we use encryption techniques. So even though you encrypt, the problem is not over. You have message that having the scope for the adversary who could alternatively who could change the bits of the information being transmitted. Even though we are not able to control tampering of data, we can identify whether there is some change in the data being transmitted. We call that as the protocol that detects such message tampering provides data integrity. The third threat, even though you implement encryption techniques, data integrity techniques, it is the third possibility of security threat is the adversary could alternatively transmit an extra copy of your message in a reply attack. He reads the data and he sends his own message which resembles the exact message being transmitted but some changes. So that modification is possible. To the website, it would appear as though you had simply ordered another of the same item you ordered first time. So reply attack causes this problem. Therefore, a protocol that detects replace provides originality, whether somebody third party has replied or the original party has replied, originality of the message has to be identified to overcome this type of threat. To achieve this, timeliness of the data is very, very important. A protocol that detects such a delaying tactics is said to provide timeliness. So, for example, what is tactics here? Suppose an adversary intercepts the order that you have made an order while you are waiting for the ordered item to be received. Then he makes the reply attack and he asks for delaying of the your order. Adversary could thereby arrange for the item to arrive on your doorstep while you are on vacation or you are not there, when it can be where it can be easily snatched. So that kind of tactics he can do. A protocol that detects such a delaying tactics is said to provide timeliness. Therefore, these are all considered as part of the data integrity. Data integrity, originality, and timeliness are considered aspects of the more general property of the integrity. Other threat to the customer is unknowingly being directed to false website. You type some website name correctly, for example, www.google.com, but it takes you to the different website. That is because of the DNS attack. Domain name server, the name service cache of the customer's computer is attacked. So there some changes are done for google.com. Instead of the particular IP address, some other incorrect IP address is introduced in the database. So address of a false website is given. A protocol that ensures that you are really talking to whom you are talking is said to provide authentication. Therefore, if a false website for which you have got directed to, then you should be able to identify the false website. Therefore, authentication is required. Authentication entails integrity, since it is meaningless to say that a message came from a certain participant if it is no longer the same message. Therefore, authentication is important. Authentication helps you to identify, ensure that you are talking to a correct Google website, correct BMSIT website, for example. So, authentication is required. So, all these problems we are keep discussing. So, in the examination, they may ask you to list and analyze various web security threats, okay, which are being discussed now. So we whatever we are discussing, all those things are important. The owner of a website can be attacked as well. Some websites have been defaced. Website is correct, but defaced. So website is defaced by some party, not the owner of the website is defacing it. Some third party adversary, what we call the adversary, he defaces it. He writes some different contents. Okay, and website contents have been remotely accessed and modified without authorization. Therefore, unauthorized person should not access your website, should not access your database. So access control is required. So a protocol which enforces the rules regarding who is allowed to do what is access control. Websites have also been subject to denial of service attacks, during which would-be customers are unable to access the website because it is being overwhelmed by bogus requests. Okay, so denial of service attack is very, very important. For example, railway reservation system may be being attacked by some people. Suppose if application has not ensured, if it has not implemented a mechanism to overcome the denial of service attacks, it can happen like this. Say one single customer holds the reservation website application and he keeps on booking all the seats in the train. The entire train, nobody uses actually, but all seats are reserved. Think of such a scenario. So that is due to denial of service attack. So actual customers who wants to use the facility are denied of service because some customer who has got the access to this application is reserving all the tickets. The TCP also, we have three-way handshake protocol. In three-way handshake protocol, once the connection is established, if the communication is not made, it is nothing but denial of service attack. If all the malicious adversary customers, TCP clients gets connected to the TCP server and nobody makes communication. Actual customers are TCP clients who wants to make the communication will not get the chance to make the communication. So that's also an example of denial of service attack. So therefore, ensuring a degree of access is required. So to what level the particular application has to be made available to whom is very, very important. On top of all these problems, security threats, you have additional notable problem called using the internet to deploy malicious code that exploits vulnerabilities in end systems. Worms, for example, pieces of self-replicating codes that spread over the networks and causes several problems, and viruses which infect the systems when the infected files or applications are transmitted over the network from one system to another system. Infected machines can then be together formed a network and called as botnets, which can be used to inflict further harm, such as launching DOS attack. So in this chapter, the outline of the chapter is to address directly or indirectly all the web security threats so far, whatever we have discussed. Cryptographic building blocks, we discuss how the key distribution has to be done, what are the different authentication protocols we can use, example systems and firewalls, all these things we discuss in this unit. In this chapter, we introduce the concept of cryptography based security step by step. The first step is the cryptographic algorithms, ciphers, and cryptographic hashes. Cryptographic algorithms are parameterized by keys. Very first, we have to understand symmetric key encryption and decryption. Friends, in this block diagram, you can see message in plain text, encrypt, and message in ciphertext. Encryption key is used. Decryption key is used. In symmetric key encryption and decryption, the same key is used both for encryption and decryption. So the key is important here. Key even though system becomes simple, securing key is important. But we have to understand that symmetric key encryption uses the same key for both encryption and decryption, whereas asymmetric key encryption uses different key. That means for encryption, a key, and decryption, some other key is used. Separate keys are used. Principles of ciphers. Encryption transforms a message in such a way that it becomes unintelligible. It won't gives any meaning to the party who reads the data, who tampers the data. An adversary will not be able to make out what message is. So in that way, we do the transformation of the original message. Okay, transformation of the original message. The original message is called plain text. The sender applies an encryption function to the original plain text message, resulting in a ciphertext message that is sent over the network. The receiver applies a secret decryption function. Receiver applies a secret decryption function, the inverse of the encryption function, to recover the original plain text. So, what algorithm he uses, what type of key he uses, if it is made known, it is easy for the attacker to make the decryption. Therefore, secret decryption function has to be used, which is the encryption, okay, which is inverse of the encryption function to recover the original plain text. Principles of ciphers. The ciphertext transmitted across the network is unintelligible.
Hello. Hello.
Sir, sir, it's
And Guru.
Kaushik ನಿಂದ್ರಲ್ಲಿ ಬರ್ತಿದೆಯಾ?
ಏನಾಯ್ತಪ್ಪ?
Sir has left the meeting.
ಏನು
ರೆಕಾರ್ಡ್ ಅಂತ
ಗುಡ್.
ರೆಕಾರ್ಡ್ ಅಂತ ಬರ್ತಿದೆ.
ಸರ್ ಲೀವ್ ಆಗಿದ್ರೆ ರೆಕಾರ್ಡ್ ಹೆಂಗಾಯ್ತದೆ?
ಆರಿಫುಲ್ಲಾ.
What's the problem?
ಜಯ ರೀ.
ಆರಿಫುಲ್ಲ
ಆರಿಫ್
ಬಿಡು.
ಆರಿಫ್
ಯಾರು
ಆರಿಫ್
ಯಾರದು? ಶಶಾಂಕ್ ಶಶಿ.
ಹರ್ಷಿತ್
ಲೋ ಶಶಾಂಕ್ ರೆಕಾರ್ಡ್ ಆಗ್ತಿದೆ.
ಆಗ್ಲಿ ಬಿಡ, ಬೈತಾ ಇಲ್ವಲ್ಲ ಏನು.
ಜೈ ಯಾರಿಗ್ ಬಂದಿದೆ?
ಹರ್ಷಿತ್ ಇವಾಗ ಬಂದೇನು? ಟಿಫನ್ ಆಯ್ತಾ?
ಮಾಡ್ಕೊಂಡೆಲ್ಲ ಫುಲ್ಲು. ಆಯ್ತು ಸರ್, ನಿಮ್ದು?
ಆರಿಫ್ಗೆ ವೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ.
ಆರಿಫ್ಗೆ ಅಂತ ವೇಟ್ ಮಾಡ್ತಾ ಇದೀಯ?
ಬರ್ತಿರ್ಲಿಲ್ಲ ಟಿಫನ್ಗೆ.
ಆರಿಫ್
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 ಯಾರು ಕರೀತಾರೆ?
ಆರಿಫ್
your network connection trying to reconnect. X-Men Logan दोनों सेम ही है ना?
ದರ್ಬಾರಲ್ಲ
ವೊಲ್ವರಿನ್.
ಕೌಶಿಕ್
ಅರೆ ಬಾ.
ಲೋ ಸರ್
ನಾನು ನಿನ್ನ ಹೊಡೆದಪ್ಪ, ನಾನು ಒಬ್ಬನೇ ಹೊಡೆದ. ಸೈಕೋ ಆಗ್ಬಿಟ್ಟಿತ್ತು, ನನಗೆ ಜಗಳ ಆಗ್ಬಿಟ್ಟು ಮಂದಿ. ಅವನೇನೈತೆ ಗೊತ್ತಾ, ಇದು
ಫನ್ನಿ
ಹರ್ಷಿತ್
ಸರ್ ಬಂದಾಗ ಹಿಂಗನ್ಬೇಕು. ಏನಿಲ್ಲ, ಏನನ್ಬೇಕಂದ್ರೆ
ಹರ್ಷಿತ್
ಯಾರು ಅದು?
ನಿಂಗೆ ಯಾಕೋ ಅದರಲ್ಲಿ ಕೂತ್ಕಲ್ಲ ಸುಮ್ಮನೆ.
ಅಖಿಲ್, ಏನೋ ನಿಂದು?
ಏನೋ ನಿಂದಳಿ,
ಏನೋ ಲೇಡಿ ವಾಯ್ಸ್ ಅಲ್ಲಿ ಕರೀತಾ ಇದೆಯಲ್ಲೋ.
ನಾನೆಲ್ಲ ಅಭಿನ ಕರಿತಿರೋದು ಲೇಡಿ ವಾಯ್ಸ್ಲಿ.
ಹರ್ಷಿತ್ ನಾನು
ಹುಡುಗಿ ವಾಯ್ಸ್ ತರ ಇದೆಯಾ? ಕ್ಲಾಸ್ ರೆಕಾರ್ಡ್ ಆಗ್ತಾರೆ ಕ್ಲಾಸು.
ನಾನಲ್ಲಪ್ಪ,
ಪವನ್ ಗೊತ್ತೇ ಇಲ್ಲ ಪವನ್.
ಹರ್ಷಿತ್
ಜೈ ಬಾಲಯ್ಯಪ್ಪನಿ.
ಹಲೋ 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 ಹರ್ಷಿತ್ ಹಲೋ ಹಲೋ.
ಯಾಕಪ್ಪ ಅಖಿಲ್?
ಲೆಫ್ಟ್ ಆಗೋದ್ನಲ್ಲ ಹರ್ಷಿತ್. ಮನೋಜ್
ಯಾಕೋ ಚೋಟು?
ಹಾಯ್ ಮನೋಜ್.
ವಿಷ್ಣು ಏನೋ ಮಾಡ್ತಿದ್ಯಾ?
ನಿಂಗೆ ಯಾಕೋ ಅದೆಲ್ಲ
ಇವಾಗ ನಿನಗೆ ಯಾಕೆ?
ಶಿಲ್ಪನಿ.
I guess there won't be any class.
ಸರಿ. రే రెహమాన్ గా ఏం చేస్తున్నావు? ಮೇ ಬಿ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅನ್ಸುತ್ತೆ, ಕ್ಲಾಸ್ ತಗೊಳಲ್ಲ.
ಕನ್ನಡ
ಏನ್ ಶಶಾಂಕ್?
ಇಲ್ಲ ಕ್ಲಾಸು.
ಶತಾಬ್ದಿ ಎಕ್ಸ್ಪ್ರೆಸ್.
ಬೇಡ ಅಭಿ ಯಾಕಾಡ್ತಾ ಇದೀಯಾ?
Akhil, yours is the worst behavior.
ಏ ಶಿವಾನಿ ಸೆಂಟ ಎಲ್ಲ ಓಕೆ.
ಇದೇ ಮಾಡು ನೀನು.
ಏನ್ರ ಎಲ್ಲ ಅಟ್ಯಾಕ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ?
ಹೌದಾ, ಸರಿ ಆಯ್ತು ಆಯ್ತು. ಸರಿ ಆಯ್ತು.
ಏ ಅಭಿ ಏನ್ರ ಅದಿ?
Please maintain some discipline.
ನೀವೇ ಮಾತಾಡ್ಬೇಕು ಅದ್ರ ಬಗ್ಗೆ.
Who is that? Who is that?
Hey, you dirty fellow.
ಬಚ್ಚಾ ನೇಂಗ ಮಾట్లాಡಿದ ಪವನ್.
ಏನು ಅಗೋರಿ?
ಆಹಾ ಆಹಾ ಲಾವಣ್ಣಯ್ಯ.
ಅಗೋರಿ ಗಾಡಿ ತೋರ್ಸಕ್ಕೆ DP ಹಾಕಿಟ್ಟಿದ್ಯಾ ಇದು?
ಈಗ ರಿಮೂವ್ ಮಾಡ್ತೀನಿ ತಡಿ ಮತ್ತೆ.
ಹೀರೋ ಏನ್ ಅನ್ಕೊಂಡಿದ್ಯಾ?
ಒದ್ದು ರವಿ ಮಚ್ಚ.
వేరే లెవెల్ రాదు.
మచ్చా లెవెల్ 1 లోనే ఉన్నా మచ్చా, ఇంకా వేరే లెవెల్ కంతా పోలేదు.
ఏంటి మచ్చా?
అరే అడేమన్నాడు ఆ రోజు?
ఎవర్రా?
వాడేరా అర్జున్ రెడ్డి.
అభి ఆఫ్ చేయరా మైకు.
ये फनी कितना वाला?
नहीं
Hello? Hello?
Yes, sir.
Yes, sir.
There are some corrections,
Yes,
right?
sir.
Hello?
Yes, sir.
Good morning,
Yes, sir.
Yes, sir.
Okay, no problem. You can answer your attendance. Anaga?
Yes, sir.
Present?
Yes, sir.
Abhilash?
Yes, sir.
Akhil?
Yes, sir.
Akrut Kumar? Akrut Kumar? Akshay? Anusha?
Yes, sir.
Arvind?
Present, sir.
Arifullah?
Yes, sir.
Benakaraj?
Akrut present, sir. Sir, Akrut present, sir.
Present, sir. Benakaraj present.
Yeah, yes. Benakaraj? Banu
Present,
Prakash? Bhargav? Bhargav present? Bhargav?
Yes, sir.
Ahmadullah?
Yes, sir.
Present, sir.
Chaitra?
Present,
Sir,
sir.
Alhamdulillah, present, sir.
Chandana? Charan Kumar?
Tagole.
Charan Kumar? Darshan?
Holding. Present. Darshan present alwa.
Diksha?
Present, sir.
Dakshayani? Kishan?
Present, sir.
Harshit?
Present, sir.
Hemalata? Uma Bushra? Jayan?
Present, sir.
Divya?
Yes, sir. Sir, Chandana present, sir.
Okay. Kaushik? Lakshmi?
Present, sir.
Kaushik is present?
Nikhil absent, sir.
Lavanya?
Present, sir.
Manish?
Present, sir.
Manoj? Manoj absent? Mohit?
Yes, sir.
Naval?
Yes, sir.
Navya?
Present, sir.
Nikhil?
Yes, sir.
Panindra?
Present, sir.
Pawan?
Present, sir.
Pooja?
Present, sir.
Purnima?
Present, sir.
Raman?
Yes, sir.
Rashmi?
Yes, sir.
Rupak Datta?
Yes, sir.
Sai Kumar?
Present, sir.
Present, sir.
Samir?
Present, sir.
Shadab Ansari?
Present, sir.
Sharan? Sharan? Shashank?
Yes, sir.
Shivani?
Present, sir.
Soumyashri? Spurti?
Present, sir.
Sri Vishnu?
Present, sir.
Sugandhini?
Present, sir.
Sushma?
Present,
Sugandhini, you have less attendance. Sushmita?
Sir, present, sir. Sugandhini.
Sushmita, you?
Present, sir.
Tirtha KB?
Present, sir.
Trupti M?
Present, sir.
Varsha?
Present, sir.
Veena? Veena?
Present, sir.
Sheetal? Santosh?
Present, sir.
Santosh?
Present, sir.
Veena present, sir.
Okay, okay. Thank you.
Sir, Akrut present.
Hemalata present, sir.
Sir, Kaushik, present, sir.
Present.
Arif, present, sir.
Absent, sir. Elder absent, sir.
Arif.
ತಗೋಲೆ